Hi, my name is Aisha. Hi, my name is Azahra.
Hi, my name is Amirul.
Hello and good day to our lecturer and fellow friends. We are from Group 5. Today we would like to present our Physic Innovation Project for course PHY210, focusing on entrepreneurship mindset.
Based on the assignment requirement, we are expected to come up with an original idea conceived in rotational mechanics and thermal physics. We have selected the item blender. However, this is no ordinary blender. We bring to you the mechano-grind blender, a fusion of modern blender technology and the traditional benefit of a mortar and pestle.
Let's look at the component of need for this innovation. What is the real-life problem that we face with conventional household blenders? This issue excessively high rotational speed.
Exactly. Conventional electric blenders rotate at a very high RPM. This is where thermal physics come into play. This high-speed rotation generates massive frictional heating between the blades and the ingredients.
Based on the principle of heat transfer, these sudden temperature spikes damage food nutrients, destroy live enzymes, and degrade heat-sensitive vitamins like vitamin C. It also alters the original flavor profile.
On the other hand, when we use a mortar and pestle, ingredients are crushed manually. No heat is generated, so the authentic flavor and nutrients are perfectly preserved. But the problem is manual crushing requires a lot of physical effort. It is slow and exhausting.
Therefore, real-life application in the culinary industry and healthy meal preparation desperately need a hybrid system, one that offers the speed of an electric blender but preserves the high quality of a traditional mortar and pestle without heat-induced nutrient loss.
Now, let's take a look at the component of approach, how the mechano-grind system works based on the physics principles.
What about thermal physics? Because the blades rotate slowly, the rotational kinetic energy produced is very low. Take a look at the kinetic energy formula.
Refer to the equation T equals to I alpha, where T is torque, I is moment of inertia, and alpha is angular acceleration. We deliberately designed the heavier grind blades to increase the system momentum of inertia with high torque. This blender can crush through ingredients like onion, chilies, and herb with high impact force, simulating a heavy mortar strike even at a low rotational speed.
So we have K rod equal to 1/2 inertia, angular velocity, power of 2. When the angular velocity is low, the kinetic energy decreases, which significantly reduces the energy converted into frictional heat. We can monitor the heat absorption through the formula. We also have Q equal to mc delta T when the heat Q generated is minimal, causing the change in temperature delta T of the food to be almost zero. As the result, the food's nutrients remain intact and the texture is perfectly uniform, just like it was crushed by a mortar and pestle.
In conclusion, the mechano-grind blender is the perfect solution driven by an entrepreneurial mindset. It perfectly bridges high torque rotational mechanics and smart thermal control to preserve the quality of our daily life. This innovation proves that combining traditional methods with modern physical can yield high value products for the market. That concludes our presentation for the PHY210 project. Thank you very much.